In this video, I'll teach you the concept and different methods to perform hatching in AUTOCAD. But before exploring this topic, we will complete this figure and try out hatching in this figure. The speciality of this exercise is that once you complete this drawing, you will get a chance to practice most of the commands and concepts taken till now. So let's get started. Here we have three polygons. The outermost polygon is a square, then the inner one is an octagon, and the innermost polygon is a rotated square. But before creating these polygons, we have to set a proper limit. The maximum dimension is 4 and there is no negative values. So I'll go to limits command. Lower left at 0, 0, upper right at 6, 6, followed by a zoom all. Now the limit is set. Next, I'll construct two intersecting lines just to show the axis. So I'll go to line command, first point, then ortho on, second point. Then again line, give an enter, first point, second point. Next, I'll go for polygon. Number of sides 4. So just give an enter, it's the default. Then you are supposed to specify the center, which is nothing but this particular intersection. Just click on that. The OSNAP is active. So you have got it. Now software is asking whether you want the polygon to be inscribed or circumscribed. Here the side length is given as 4. Such a polygon can be assumed to be circumscribed about a circle with a diameter of 4 units. So let's go for circumscribed option. Then it will ask you for the radius of the circle. Since the diameter is 4, I'll give the radius as 2. So the square is created. If you have any difficulty in understanding how this polygon is created, I'll draw a circle with the 3-point option. 1, 2 and the 3-point. This is an imaginary circle about which this polygon was circumscribed. And the diameter of this imaginary circle is this 4 units. Okay, so that is how I have constructed this polygon. Now I'll erase the circle. Next, I'll create this octagon. So I'll go for polygon again. When I'm asked to give the number of sides, I'll give 8. Then I'm asked to specify the center of the polygon, which is this intersection. Click on that. Now it is asking whether you want the polygon to be inscribed or circumscribed. I want the polygon to be circumscribed. Now it will ask you for the radius of the polygon. Here, the octagon 3 across is the information given. Across means width across flat sides. That means this distance is 3 and this is 3 and this is 3. So you can imagine this octagon to be circumscribed about a circle with the 3 unit as the diameter. Now it will ask you for the radius. Radius is half of it, which is 1.5. So that polygon is constructed. Next we have to create this square. Again polygon command you can repeat. Number of side is 4. Center is the same intersection. Now you can choose again the circumscribed option. Now this square can be imagined to be circumscribed about a circle with a diameter of 1.38. So the radius is half of it, which is 0.69. Now I should rotate this because it's a rotated square. So I'll go for rotate command and select the square. The intersection is the base point of rotation and rotation angle is 45 degrees. Next I'll create these arcs at the corners of the outer square as well as the circles at the midpoint of the alternate edge of the octagon. I'll use circle command to create both. So I'll go for center radius method of circle. I'll pick this as a center point of the circle. Then radius is given as R.54. So I can give that value. Next I'll create this particular circle. And the diameter of the circle is given as 0.5. So the radius is 0.25. So again circle with the center radius. I'll pick this as a center and the radius is 0.25. Next I can create the copies of the same circles on other sides using the array command. So I'll go for array classic. Then I'll select these two circles as the objects to be arrayed. Then I'll go for polar array. The number of items is actually 4, so you don't have to change it. Angle to fill 360, even that can be retained. Now I should specify the center point of the array, which is this particular intersection. Now you can just preview the array. Now I'll give OK to get the array on the screen. Next, I'm going to erase these lines since they are just construction lines, and I'll also perform some trimming to make these circles into arcs. Before that, I would like to indicate the center using a point, because even after erasing these two lines, you should still be in a position to locate this point. So I'll go for point command, PO. Now I'll just click to define this intersection point. Next, I'll give erase command and I'll erase these two lines. Okay, you have got that point there. Now I'll go for trim. When I'm asked to select cutting edges, just give an enter. Then using a crossing window, you can select all these objects that are to be trimmed off. You can also perform trimming inside these circles. Okay, so hence you can complete this figure. Next, I'll complete the same figure by applying the concept of blocks in this. So what I'll do is, I'll make just quarter of it or 1/4 of it and remove the rest of the portions. Then I'll make a block of that particular object. Then by changing the rotation angle, I'll complete the figure. Let's see that. I'll draw a line from this node straight up. Then one more line from this endpoint towards right side. Okay, these lines are just cutting edges. Then I'll go for trim. And using these two objects as a cutting edge, I'll trim off this portion and this particular half of the circle, this edge, and whatever is crossing these lines. Rest of the objects can be erased. Then I'll also erase these two cutting edges which I've drawn just now. Next, I'll give block command. So block can be taken from the home tab as we have seen in the last video. This time I'm going to create a block by selecting the block command from the insert tab. So I'll click on insert tab and I'll choose create block. We also have right block or W block option available here. So I'll go for create block. It'll ask you for a block name. I'll call it as part. Then the base point or the insertion point is this particular node. That is the reason why I have kept this point here. Now select objects. I'll select all these objects excluding the node. Now here you can select delete and give OK. So that block got deleted, and as you know, the block definition is created. Next, I'll go for an insertion of the same block. So I'll go to insert and you can see the definition here, and you can choose the base point as this particular node. Next, I'll click on insert, more options. This time I'll give a rotation angle of 90 degree in the dialog box. Now click here to insert it. This is nothing but a 90 degree rotated version of the same block. Insert, more options, rotation angle is 180, and I'll choose the same insertion point. Then one more insertion with rotation angle of 270, the same insertion point. Hence, simply by changing the rotation angles, you have completed this figure after making 1/4 of it as a block. This is another approach to complete the same figure. I have provided this image of the figure. Along with this video, you can download this image and you can try it on your own. Next, we will try the concept of hatching in this figure. Hatching in AutoCAD is also called pattern filling, because while you perform hatching, we fill certain predefined areas with predefined patterns. When you go through this figure, you can locate several areas. For example, we have an outermost area here, then we have this intermediate area followed by an innermost area, and we also have small areas within each circles. Using hatch command, we can fill in these areas with any desired patterns with suitable parameters and styles. You can perform hatching in AutoCAD in two different ways. You can either type the letter H at the keyboard to get the hatch command invoked, or else you can choose the hatch command from the drop panel of the home tab. Just click on the hatch command. When you invoke this command, you will get a new hatch creation tab on the ribbon, wherein you can see all the properties and parameters related with hatch. First of all, you have to specify the type of pattern. The pattern can be either a solid fill. When you choose solid fill, you can fill the areas with a single solid color. That color can be chosen from here. By default, it goes for the bilayer option. That means the color given to the layer, or else you can choose any desired color from the color palette. Then next we have the gradient option. In the gradient, you will get a smooth gradation or transition between two colors. And there are different types of gradients which are displayed. We will see that. Then we have the pattern option. Pattern means any desired pattern. The patterns are categorized as ANSI patterns, which are different materials like brass, bronze, copper, steel, etc. Some pattern starts with AR, which stands for architectural patterns. And depending upon your requirement, you can choose any desired pattern. In fact, the gradient fill and solid fill and everything is given in this list. Now I would like to go for the honey pattern, for example. So I've chosen this pattern. Now the software is asking to pick an internal point. When you pick an internal point, the software identifies the area using the ray casting method. In the ray casting method, the software emits imaginary rays radially into all directions from the picked point, and it identifies the boundaries which are hit by this ray. So when I keep the cursor here, this boundary is identified. When I keep it here, this is identified. Now I would like to keep the cursor here. Hatching is performed in the outermost area as well as the next alternate area. That is because in AutoCAD there is a style called hatching style. When you click on options, and here you have normal island detection style. In normal island detection, what happens is the software hatches the alternate areas. If you go for outer, only the outermost area will get hatched. If you go for ignore, the software hatches the entire figure as if it is made up of a single boundary. Now I would like to go for the outer style. So the outermost area is hatched. If you want, you can change the scale. Present scale is 0.055. If you just click on this arrow, you can enlarge or you can reduce the scale. You can also change the rotation angle by providing a suitable rotation angle. Here, you can either type a value or else you can just drag it over here so that that value will get changed. You can also provide a transparency for the hatch pattern so that hatch patterns won't be that prominent and the boundaries will stand out. You can provide a suitable color for the pattern. I'll choose this particular green shade. You can also go for a background color. I'll select, for example, this background color. So likewise, you can have a hatch color as well as a background color. If you are satisfied with the pattern and the parameters, you can apply the hatch patterns by clicking on the Close Hatch Creation button. You can also make use of solid fill or gradient fill while performing the hatch. The solid fill is available in the hatch command. To get solid fill, I'll give hatch command again. And here the solid is selected. Now we'll just pick a point inside and you can see that that particular area is filled with a solid color. Now if you're satisfied with it, you can just give Close Hatch Creation. Just as we have seen before, the gradient fill will appear as a pattern among the different types of patterns. Or else you can directly choose gradient fill from here. So I'll just click on gradient. We have different types of gradients such as spherical, hemispherical, curved, inverse, spherical, etc. I'll choose a spherical and I'll pick an inside point here. Just pick a point and you can see that it has applied a spherical gradient hatching. And you can change the gradient colors from here. You can start with this particular color and you can end in this yellow or in a different color. I'll go for inverse gradient and you will get it like this. That is inverse gradient, or it can be the normal gradient. So this is how you perform hatching using gradients. I'll give hatch command again, and here we have already discussed the solid pattern, gradient pattern, as well as pattern option, which means that all the patterns available in the hatching library of the software. But as the last option, we have user defined here. It is not the one which is defined by the user, but it is the most frequently used hatch pattern, which is parallel lines. Whenever a section needs to be indicated, as well as for a number of other applications, we use parallel lines. And now I'll just click a point inside, as well as here and here and here. But here the scale is little high, so we have to reduce it. You have reduced the spacing between the parallel lines. You can also change the angle of the parallel lines like this. Now you can change the color. Let it be this yellow. Okay, likewise I'll give a thematic color for all the different patterns. So that's the meaning of user defined. Now I'll close the hatch editor. You can easily edit an existing hatch pattern. For that, what you have to do is just click on the pattern to be edited. The moment you click there, you will see all the parameters related with the hatch pattern appearing in the hatch editor tab. Now if you want, you can change the pattern simply by clicking on a different pattern. Now you can see that the pattern got changed. If you want, you can make it hex or gravel or any other pattern. The color can also be changed by clicking. The pattern color, even the background color can be changed, or you can just replace the background color. Hence, any desired editing operation can be done simply by clicking on the hatch pattern, and you can access those parameters. Now when you look at the boundaries panel, you have various options. The pick point option is what you have used now to specify the boundaries, but the boundary can also be specified using the select object method. So if you want to define the boundaries using select object method, the boundary should be closed and continuous. That means there should not be any gaps or overlaps in the boundaries. So in this context, this is not a continuous boundary. We can see some break here. So that is the reason why I have used pick point method. Then you can remove a boundary from an existing boundary set. You can also recreate boundaries. That means in AutoCAD, you can recreate a boundary from an existing hatch. For that, what you have to do is select the hatch and you click on a recreate option. Now here, AutoCAD will ask you whether you want the boundary to be a polyline or a region. I'll choose polyline. Again, one more prompt. Associate hash with the new boundary. I want the hash patterns to be associated with the new boundary. Let's see what happens. So I'll give yes. When you look at this pattern, you can see that it has got an outer boundary as well as an inner boundary. These two boundaries are recreated by the software. So I'll just click here. I have got the selection dialog, and here I have a polyline option. So this polyline was created by the software when I have used the create boundary option. Now I'll just click on the center grip and I'll move the mouse. Now you can see that the hash pattern will move along with the boundary. This is called the associative hatching. So in associative hatching, changes performed on the boundary will get instantly reflected on the pattern. Now I'll undo this change. In AutoCAD, you can temporarily suppress the display of hash patterns using a command. For that, you can give fill command. Fill mode can be in the on state or in the off state. Presently, it is in the on state. I'll just turn it off. Now, if you want the changes to be updated on the display, we have to give a regen command. So you can type RE. RE stands for regeneration. Now the display of hash patterns are suppressed. Now whenever you want to get it back, you can go to fill command and you can turn it on. Again, you have to give a regen. Now when you click on this boundary, you can see that we have an arc here and there is another arc here. Likewise, it's all segmented. Now when you click over here, we have a polyline which is created as a result of create boundary option which was executed before. And now when you look at this area, you can see that it is bounded by two boundaries. The first boundary goes like this. The next boundary is created by this rotated square. Suppose if I want this particular outer boundary of this area to be traced automatically, what you can do is you can go to hatch and we have a boundary command. So when you just click on the boundary command, it will give you a boundary creation dialog. Over here, we have the same pick point method. So just click on pick point and using raycasting, it will trace the boundary automatically. Now give an enter. Now it has created this particular outer boundary as well as this inner boundary of this area. Now you can give move command and you can separate out these two boundaries. And this is the base point and second point. Suppose if you do not have a hash pattern, but still if you want to create a boundary, using the raycasting method, you can make use of the boundary command. Now I'll go to fill command, I'll turn it on, and I'll give a region to get the filled areas back. I'll go to hatch command again. Here, now I'll use the select object method. And I can very well choose these two boundaries because these two boundaries are closed and continuous. Now software has performed hatching within this area as per the specified style. Next, I'll take a copy of this inner boundary using the copy command. And this is the base point and this is the second point. Now when I try to perform hatching within this area using the hatch command, let's see what happens. You can see that the most recently performed hatch pattern, which is the gravel pattern, will appear as the default pattern. Suppose if you want to perform hatching within this area with this pattern and its parameters, you have an option called match properties. So when you click on match properties, you will get two additional options. One is use current origin. Next one is use the source hatch origin. The hatch pattern has got an origin point. In fact, hatching starts from this origin point and it remains invisible till it encounters the boundary. The moment it encounters a boundary, it will get automatically turned on. It will get turned on and off depending upon the style chosen by the user. As we have seen before, the style can be normal, outer or ignore. Now what I'll do is I'll use the current origin of the existing hatch pattern. So I'll click on current origin and it will ask you to select the hatch object, which is this particular object. Now it will ask you to select an internal point. I'll pick this internal point and just give an enter. You can see that the software has performed hatching with the selected pattern and its parameters. So that's the use of match properties. Now we have discussed the concept of hatching and we have seen almost all options related with hatching.